Hi, welcome to complex analysis. This is fifth session on path integral. See, we defined path integral and looked at lot of examples, computed lot of path integrals, and we also established some properties of path integral. Right now, if you have been follower of mine about analysis, integrals are you should know integrals are very difficult to compute explicitly. So one of the most important thing is you should learn how to estimate. Right. So, is there an estimate for path integral? That's a question we want to ask and answer it today. And once we get an estimate, we will also look at applications. Okay, let's go ahead. So, the question is the following. Suppose f is from gamma containing u to c continuous. Okay, and we are defining integral of f over gamma. I want to know whether I can estimate this. There is an estimate, right? So as I have been saying, whenever I look at path integral, what should I do? There is an obvious guess. I will come to that. Okay, I should always okay. Let me assume is so C1 or it's actually piecewise. What okay? So the obvious thing is you have to write down the definition. This is A to B f of gamma t in gamma prime t dt. Now let's look at this. If I define gt to be f of gamma t gamma prime t dt, then this is integral g of t dt from A to B. And we know how to estimate. This is less than or equal to integral mod g of t dt. Okay, this we had already seen, right? Therefore, modulus of integral of f over gamma is less than or equal to integral A to B modulus of f of gamma t into modulus of gamma prime t dt. Right? Now, what do I know about f? F is continuous function from, therefore f composite gamma is a continuous function from AB to C. Therefore there exists an m which is greater than, let us assume greater than 0, so that for all t in AB modulus f of gamma t is less than or equal to m. Let me see, make sure I share the screen. Yeah, right. Therefore this is less than or equal to m times a mod gamma prime t dt. Okay, now notice that once gamma is given and gamma prime, if you want, you maybe this may be equal to actually something like I equal to 1 to n if gamma prime t dt modulus. Okay, this is ti minus 1 to ti in case gamma is piecewise c1, right? Otherwise this is the thing. Okay, so once gamma is given, this number depends only on gamma. Notice that these are all finite because gamma prime, this is a closed and bounded interval ti minus 1 to ti. Gamma prime is continuous. Modulus gamma prime t going to modulus gamma prime is continuous. Therefore this is a finite number. There are a finite sum. Therefore this is a finite number. Do you understand? So we denote this constant by L of gamma. Right? Therefore I found an estimate for integral mod f over gamma which is less than or equal to m times L of gamma, where m is, if you want, the LEB of mod f of gamma t as t varies over AB or any upper bound, that will do, right? I don't know to find upper bound. M is said that f of gamma t modulus is less than or equal to m for all t in AB. Okay, any upper bound will do. I will get an estimate, right? So this is the so-called ML inequality for path integral. Or path integral, right? Of course, there is a geometric meaning for L of gamma. Okay, if you have done vector analysis or several variable calculus, multivariable calculus, you know that if gamma is a continuous thing, say C1 thing into, let us say, into Rn, right? Then I can think of gamma prime t as the velocity vector. Okay, so this is gamma. Okay, this is gamma A, this is gamma B, and this is the gamma prime t. This is a tangent vector or velocity vector at the right. Therefore, norm of that gamma prime t is the speed, right? So, what is the intuitive physical idea we think of gamma? Gamma is the path traversed by a particle. At time A, it starts at gamma A. At time B, it stops at gamma B. And gamma prime t is the velocity, instantaneous velocity at the instant t. Therefore, what is the speed of the particle at instant t? Norm of gamma prime t. Therefore, the how much distance it travel when it moves along thing. As you know, the distance is time times speed, right? Now, so what do? You break the interval AB into very fine partitions. Therefore, on this you can simply think of this as a path, right? Therefore, the length of gamma is defined to be integral AB to norm of gamma prime t dt. This is the geometric meaning. So, in gamma is a path, okay, piecewise smooth path, okay, then we call L of gamma as the length of gamma. What is this? By definition, this is integral ti minus 1 to ti mod gamma prime t dt, and I running from 0 to n, right? So just to make sure that you know why we call it a length, let us just look at two examples, right? Let us say gamma t equal to a plus r e power I t, 0 less than equal to t less than equal to 2 pi, right? Then what is gamma prime t? R I e power I t. Therefore, what is modulus gamma prime t? Simply r. Therefore, what is 0 to 2 pi of mod gamma prime t? That is 0 to 2 pi r dt. This is 2 pi r. That is the length of the circle, right? That's one example. Second example, that should have been the first example. Let us start with 2 points z and w in u, so that the line segment zw is contained in u. Then let's look at the line segment path z plus t times w minus z, right? So this is my thing, and this is my z, this is my w, this is the line segment, right? Now what is gamma prime t? This we had already computed, it's minus wz. Therefore, modulus of gamma prime t is mod w minus z. Notice that is independent of t. Therefore, what is length of gamma? Length of gamma is 0 to 1. This is 0 less than equal to t less than equal to 1 of modulus gamma prime t dt. But that's a constant, right? 0 to 1 mod w minus z dt, which is equal to mod w minus z. Therefore, it's the length of the line segment, right? Okay. Now suppose here instead I make it twice. What do you think it will happen? there will be a 2 here, there will be 2 here, I will have a 4 pi r. What does it mean? It means that as I said earlier, it starts from here, goes here once, at pi it comes back, and again it goes one more time, comes back. Therefore, if you think of a train, along the circle it travels twice. Therefore, how much distance it travel? 2 pi r times 2, which is 4 pi r. Yeah? And what happens if it travels and clockwise direction? Still it's the same thing because you are taking modulus. Are you following? Yeah. Please go through, pause, review, proceed. So, let us recall what is the thing. Integral of f over gamma modulus is length into a length of gamma, where length of gamma, I will simply write it like this, but with the proper interpretation. If it is piecewise, then you have to write it over the subintervals. Okay, this is the correct inequality. See, there is a common mistake by students which you should avoid. We already know integral of f modulus. We always think of integral of mod f, right? So the common mistake many times students write is this. This is wrong. Why this is wrong? Let us look at a very simple example, right? So we had already seen that. Suppose I take f of z equal to 1 by z minus a and gamma of t equal to a plus r e power I t. Right? 0 less than equal to t less than equal to 2 pi. Right? Therefore, yeah, this is the thing. I have a and this is a. Now, what is integral of gamma t? See, gamma t is this. Therefore, this is 1 by gamma t minus a. This is 1 by r e power I t. Therefore, integral f of gamma t in modulus is 1 by r. Therefore, my m I can take as 1 by r. Okay, keep that in mind. But let's go back. Right. So, f of gamma of t modulus is 1 by r, a constant. Right. Now it has a primitive. Namely, let us look at g of z equal to z by r, then g prime of z is 1 by r. Right? Therefore, integral of this modulus f of gamma t dt is g of z by r between 0 and 2 pi. Right? Are you following? What is this? This is e power I t r e power I t by r between 0 and 2 pi, which is 0. Okay, if you want a simpler example, take f of z equal to 1 by z and gamma t equal to e power I t. Right? Therefore, f of gamma t equal to 1 by e power I t, which is e power minus I t. Therefore, modulus of f of gamma t is 1 for all t. Therefore, I want to integrate this over gamma, right? But this is 0 because if I take g of z equal to z, okay, g prime of z is 1. Therefore, this is, and we know whenever there is a primitive, okay, and the path is closed, integral of path integral is 0, right? F as a primitive, namely equal to g prime, and gamma closed, okay, then integral of f over gamma is 0. right? This we know, therefore this is 0. But we already know 1 by z minus a over gamma is 2 pi I. Similarly, 1 by z over the circle gamma, this is also 2 pi I. Are you following? Therefore, modulus of integral f over gamma is 2 pi, whereas integral of mod f over gamma is 0. Hence, modulus of integral f over gamma is less than or equal to integral of mod f over gamma is nonsense. Okay. So I am giving this example because I have seen a good student who had taken a good 2 courses in complex analysis under a very good complex analyst making this mistake in an interview. Okay, she said modulus of integral f over gamma is less than or equal to integral over gamma of mod f. Okay, then I have to give her example. So the correct thing is the ML inequality. So again, remember what is the trick? Whenever you see a path integral, go back to the definition of path integral, then apply. That's what we did. Okay, let me go back. This is what we did. So integral of f over gamma, I wrote it what it is. Yeah, then what did I do? Then took modulus, but then it becomes okay, integral of a complex valued continuous function on an interval. We know how to estimate, we used it. Then luckily what happened was we got integral a to b of mod gamma prime t dt, which depend only on gamma. It has nothing to do with the function. Okay, so that's a constant which is associated to gamma. We call it L of gamma. Okay, the geometric meaning is it is the length of gamma. Okay, but otherwise we know what it is. Okay, that's it. Are you happy with that? Okay. Now let's give some applications. So pause, review, proceed. Now we will look at applications. So the first application is, suppose f and f are continuous functions on gamma to c. As usual, gamma is a path, okay, etc. Right? And let's assume fn converges to f uniformly on gamma. This means converges uniformly on the set gamma. Gamma is a subset of u. Remember, whenever you want to talk about uniform convergence, it's over a set. Right? Okay. So what does that mean? Let's recall quickly. That is, for every epsilon positive, there is an n, so that for every t in AB, for every point in the trace of gamma, but every point in the trace of gamma is of the form gamma t for some t. Therefore, for every t in gamma t, what happens? Okay, fn of, and for every n greater than equal to capital N, fn of gamma t minus f of gamma t is less than epsilon. Okay, remember that. Now, since fn are continuous, since fn converges to f uniformly, f is also continuous, right? That you know, right? Therefore, integral of fn over gamma makes sense. Integral of f over gamma makes sense. What is the question I should ask now? Yes, integral f and gamma, does it converge to integral f over gamma? Notice that these are all complex numbers. This is a sequence of complex numbers. Does it converge to sequence of complex number? So what does it mean? What is it I have to estimate? I have to estimate mod f1 gamma minus f gamma, right, in modulus. The first thing I know is path integral is complex linear. In particular, it's linear, it's additive. Therefore, this is same as modulus integral of f1 minus f over gamma. If you want to write, you can write at z, etc., but I am not writing. But what do we know about this? Okay. Now we have to use ML inequality. How will I use ML inequality? What is that I have to prove? There is an f. So you are going to give me an epsilon, right? Now what do I know? Go back. There is a natural number so that for every gamma t, this is right. Therefore, if n is greater than or equal to capital N, okay, let us look at, I want an estimate for fn of t, fn of gamma t minus f of gamma t, right? This is for every t in AB. I want an estimate, right? But if what I know is if n is greater than or equal to capital N, this is less than epsilon. So I can take my m to be epsilon, but then restrict n greater than or equal to n, right? So that is my m. Then therefore this is less than or equal to m times epsilon, right, by ML inequality. M times epsilon to length of gamma. Sorry, not m times, I'm sorry. My m is epsilon, therefore it's epsilon times length of gamma. Are you following? So I have to do, okay, supremum of modulus fn of gamma t minus f of gamma t, where t lies in the interval AB. Do I know how to estimate this? Yes, I know how to estimate this if I know n is greater than or equal to capital N. Then in that case, this is less than epsilon, or less than or equal to epsilon if you want. Okay, no problem, right? Therefore, my m I can take to be epsilon. Okay, therefore it is going, this fellow by ML inequality, this is going to be less than or equal to epsilon times length of gamma. But remember, length of gamma is a finite number. If you wanted, I could also taken epsilon by m, length of gamma. Then I would have got this epsilon by length of gamma. Therefore, it is equal to epsilon. So we have proved if n is greater than or equal to capital N, integral of fn minus integral of f in modulus is less than or equal to epsilon. Hence, integral of fn converges to integral of f. If you want strict less than epsilon, I could again taken epsilon by 2 times length of gamma. Okay, choose n so that for n greater than or equal to capital N, mod fn of gamma t minus f of gamma t is less than epsilon by 2 times length of gamma. Therefore, supremum will be less than or equal to 2 times length of gamma, etc. Okay. So pause, review, proceed. The second application is for a series. Suppose f1s are series, okay, continuous functions, okay, from perhaps gamma to c, right, and so that f1 converges uniformly and absolutely on gamma. So I don't have to repeat this, I hope. You simply take xn to be summation fk, k equal to 1 to n, then Sn converges uniformly. Okay, so the limit, okay, converges uniformly to something, call it as f, right? Then what is that I want to say? So let f equal to limit of Sn, okay, therefore that means f of gamma t for every t equal to limit Sn of gamma t, because uniform convergence implies pointwise convergence. Okay, so I get a function, right? So what is the question? Integral of f over gamma, I want to say it's same as integral of fn over gamma, this is over n. For how many of it's obvious? We have done that such things in Riemann integral for real valued function. If you have known that, this is the same proof. Because what do? Let us look at Sn. It converges to F uniformly on gamma. Remember, gamma is therefore continuous. Therefore, what do I know? Integral of Sn over gamma converges to integral of F over gamma. But what is integral of Sn? This is finite sum Fk, k equal to 1 to n. But path integral is a linear, okay, therefore it is summation Fk over gamma k equal to 1 to n. This converges to integral of F, right? Are you following? This means what? Fk k equal to 1 to infinity equal to integral of F. This implies that. Yeah, I hope all of you are comfortable with the infinite series. I am just using this. So call these things as AK. So summation AK k equal to 1 to n converges to integral of F, right? That means the partial sums converge. Therefore, that means the series an 1 equal to n equal to integral of F. But what is an? It is integral of Fn over gamma. Okay. So pause, review, proceed. Right? So as an immediate corollary, let us assume my f of z is, let us say, Cn z minus a power n from 0 to infinity. This is a convergent power series with a positive radius of convergence r. Right? Let gamma be a closed path. In B0R. Right? Okay? Right? Okay. Now, there is something you have to look at. Let us look at. So, this is my, sorry, picture should be very nice. So, let us say BAR. So, let me say. So, let us look at BAR. This is my gamma. Right? So, the first thing you should notice is, if you don't want this gamma, let us look at, okay, gamma r of t equal to a r e power I t 0 less than or less than capital R. Okay, right? Now I want to know what is integral of f over gamma r. But this is same as integral of f is summation Cn z minus a to the power n is from 0 to infinity of over gamma. Right? Now notice that gamma r is completely contained. Right? So if I choose an r less than rho less than capital R, if I choose rho like that, okay, my BAR is the circle, the closed ball BAR, in particular the circle, okay, gamma R is contained in BA rho. And I know the power series converges uniformly on any smaller disk BA rho. In particular, the power series converges summation Cn z minus a to the power n equal to 0 to infinity converges uniformly on gamma r. Therefore, by earlier thing, I know this is nothing other than Cn integral 0 to infinity over gamma r of z minus a to the power n. But we know this is 0. Therefore, the sum is 0. Yeah? Please pause. Review, proceed. So, I expect all of your master students. So, I may not, if you have seen my earlier things like real analysis, linear algebra, etc., I was extremely slow there. Okay, but I expect that you have gone through those and your analysis is very good. That's why I'm doing all these things. Are you following? Yeah, very good. So we had done some beautiful applications, and there is one more beautiful application. With that, I will stop this session. So let us recall, we proved the following result. Okay, as usual, gamma is a path in U. F is a continuous function on gamma to C, right? If there exists G holomorphic on U so that G dash of gamma T equal to F of gamma T for all T in AB, then we know integral of F over gamma is 0 for any closed path. Right? So let gamma be, recall, let gamma be a closed path. In U, okay, and let's assume there is a holomorphic function on all of U so that when restricted to gamma, the trace of gamma, G prime equal to F. Then we know integral of F over gamma is 0 because it depends only on the endpoints, but the endpoints are the same, right? Now is the converse true is what we want to look at. So we want to prove the following theorem. Okay, let U be connected open set and C non-empty of course. Okay, right. If you don't like connected, you can assume it's a convex, star shaped, etc. Convex all of you know perhaps, so assume convex if you want, or if you don't like it, assume it's a no open disk. Okay, and let F from U to C be continuous. Then there exists a G from U to C holomorphic if and only if integral of F over gamma is 0 for any closed path gamma in U. Please understand what just now what you have seen. You have seen that if I have a closed path, a continuous function on its trace, and such that it admits a primitive on the trace, that means it's actually the function should be holomorphic on the entire open set. Okay, when restricted to the trace of gamma, okay, the derivative coincides with F. Then we have seen integral of F for gamma is 0. This now the converse is given. Suppose I have a continuous function on all of U. Then I want to know whether it has a primitive on U. What does it mean? I am asking whether there is a function G so that whether G dash equal to F on U. G must be holomorphic, right? So it says, and the condition is find the path integral of F over any closed path. If it is 0, then there exists such a G. Take some time, understand. Okay, if you notice, if you have gone through my what is complex analysis about, it says something about local primitive. Okay, when does primitives exist? It gives a condition. Okay, right. Now let's go through the proof. Now I want to prove this. Where will I find G? How do I find G? Recall, I already told you if it's a fundamental theorem of calculus, if f is a real valued function from a, b to r, which is continuous, then finding such a G is easy. Only I have to define G of x to be integral a to x f of t dt. Right? Then fundamental theorem says G prime is f on AB. Right? So this gives us an idea about G. Right? The first thing is, these are the small things we want us to assume. That's why if you want, you can assume it's a convex, okay, but that's not necessary. We will see that, okay. So given an open set is connected, okay, this is something which I have to say, that if you an open set, this is U is connected if only if it is path connected, okay, right. If you don't like it, assume U is convex. Then if it is convex given, okay, fix a point A, then I can do that, okay. So fix A in U and take Z to be in U, then the line segment A to Z will be contained in U if it is convex, right. If it is only path connected open set, and hence is a path connected open set, okay, there is a path gamma, so that, and I don't want to give the domain for such thing, okay, a path gamma, so that the initial point, there exists gamma, so the initial point of gamma is A and terminal point of gamma is Z, okay. So something like, I have A, okay, this may be Z, this may be my gamma, right. Are you following? And if it is convex, I have A some point and I have the line segment Z. So what do you think, how do you think I should define G of Z? Remember the what I recalled about path fundamental theorem of calculus? So obvious thing will be to define integral over gamma of F, where gamma is a path from A to Z. This is like indefinite integral. But see, now if it is convex, there is an obvious path, namely I can take the line segment from A to Z. But it is a connected open set, I do not know which path it is, okay. So somebody may find some path gamma, another fellow may find some other path like this, okay. From here to here, this may be your A, this may be your Z. I may find a path like this, or I may find a path like this, or you may find a path like this, okay. So GZ has to be well defined, okay. So the question is, there exist so many paths, there may exist, at least if you want to say, from A to Z. Is G well defined? That's the first question. Yeah. Now suppose gamma and sigma are paths from A to Z. Then let's look at sigma till the reverse path. This is a path from Z to A, right? Therefore, let me look at gamma followed by sigma tilde. This is the juxtaposition. Gamma is a path which goes from A to Z. Sigma tilde is a path which comes from Z to A. Then we know this is a path from A to A. Therefore, it's a closed path. Right? Since it's a closed path, integral F over sigma tilde star gamma is 0 by hypothesis. But we know this, in the last session we proved this. This is integral of this plus integral of F over gamma, right? So, but then we know integral of the reverse path is minus of integral F over sigma plus integral of F over gamma. That means integral of F over gamma is integral of F over sigma, but that's our definition of g of z. Therefore g of z is well defined. Okay, make sure you understand this. If you are done multivariable calculus in the line integral, if it's a if it's a conservative vector field, that is a vector field capital F comes as a gradient of a scalar valued function, you must have seen all these things. But from my experience, many students do not appreciate vector analysis theorems, etc., especially if you are so-called pure mathematics student. Somehow the teachers don't do a good job of that, and with the result students also get the same attitude. Okay, they don't know to learn it properly. Yeah, come back. So what have we done? So let us recall. So given any z, we fixed an a in u. Given any z, look for a path which connects a to z and define g of z to be integral of f over gamma, and we saw this is well defined. Okay, now what do you want to show? Some of you keep complaining my handwriting. Okay, so we want to show g is differentiable and g dash z is f of z for every z in u. This is all we want to prove. Yeah, let us do that. So let us go slow again. So I have a, I have z, then remember z is in u and u is open, therefore there exists some small r such that bzr is contained in u. Therefore, okay, that means if I take mod h less than r, okay, z plus h will be in u, right? So I am just taking some z plus h nearby. This is z plus h, right? Okay, now actually z plus h belong to where? In bzr. Why? Because mod z plus h minus z equal to mod h, which is less than r. Therefore z plus h belong to that. Is that clear? Now what do I know about bz plus bzr? This is convex. Therefore the line segment z to z plus h is contained in bzr. All these things we had already seen, right? Therefore this line segment is already there. Yeah, therefore I can think of g of z plus h as this. Okay, this path, suppose this is the path gamma, therefore I can think of this as a path, okay, z to z plus h composed with gamma of f. And remember, my g is well defined, independent of the path. We had already seen that. Therefore it does not matter what path I take from a to z plus h, because there may be another path z plus h. Okay, there may be another path with z plus h. There may be another path to z plus h. I don't care. Okay, what the path I have chosen is gamma, go from a to z by gamma, and then from z to z plus h go by the line segment. Have you understood? Make sure that you understand all these things. Right? Therefore g of z plus h is, okay, over gamma of f plus f over z to z plus h. Therefore g of z plus h minus g of z is integral of f over z to z plus h. Okay, do you understand? G of this is g. Sorry, it looks like f. Therefore g of z plus h minus g of z by h is 1 by h z to z plus h of f. Right? Now what do I want to show? I want to show it converges to f of z. Right? Therefore, what should I estimate? I should estimate g of z plus h minus g of z by h minus f of z. Right? Therefore, I have to estimate 1 by h integral of f z to z plus h minus f of z. Okay. Those of you who have gone through fundamental theorem of calculus proof, you will see exactly the same proof. Okay. The basic ideas are the same. Okay. I recall fundamental theorem of calculus. Do you remember real analysis? Okay. Please go through it. These are the equation. If you are not sure, go back to my Riemann integrals. There I have proved fundamental theorem of calculus, or take any book, go through the proof once. Okay, this is how you make sure that you are very confident about this kind of analysis. You simply should not assume this is different. It's exactly the same proof. The trick here, because I'm going to use the trick. Okay, so if you want to do, let me just use variable now. This is f of w dw over the z to z plus h. Right? Now f of z is, remember z is fixed now. Right? F of z is a constant, therefore I can integrate it over to z plus h. This is my path, f of z. Right? Then what is this? This is f of z into z plus h minus h. Right? Because if I integrate, okay, a constant over a path integral gamma, constant c, what do I get? Okay, a to b c gamma prime t dt. This is gamma b minus gamma a times c, and here z plus h minus h. Therefore, this is f of z into h. Do you follow that? Yeah. Therefore, I can rewrite this. Okay, call this one. I rewrite this z plus h minus g of z minus h by f of z equal to 1 by h integral f w over z to z plus w, right, minus integral f of z to z plus h. This is why if you have gone through fundamental theorem of calculus in real analysis, you will see the proof is no different. It's exactly the same trick. Right? Therefore, I want to estimate this fellow. Therefore, this is less than or equal to, first, let us do that. But this is equal to 1 by h by linearity of the integral. This is f of w minus f of z by z to z plus w. Remember, f is defined. F is a continuous function on all of u, and hence it is defined here. Z plus h etc. are all defined. F of w is defined for every w on the line integral also, because everything is in BZR is contained in u, etc. Keep that in mind. Okay. Now therefore, what I have to do? I have to use ML inequality. That means I have to estimate f of w minus f of z for w in z to z plus h. Right? But what do I know about f? F is continuous. Right? On all of you, in particular z. Therefore, if you give an epsilon, there is a delta positive, such that if mod h is less than delta, f of w minus f of z is less than epsilon. Right? Therefore, for every w in z to z plus h, where mod h is less than delta, okay, I have this inequality. Therefore, w in z to z plus h of mod f of w minus f of z is less than epsilon. If you want less than or equal to epsilon. Okay, I don't care about such things. Therefore, by ML inequality, mod g of z plus h minus g of z by h minus f of z is less than or equal to 1 by mod h into epsilon into length of z to z plus h, right? But this is, we had already seen for line segment, length of the interval is the distance between the end point, therefore it's mod h. Therefore mod h and mod get cancelled, therefore it's equal to epsilon. So whenever 0 less than or equal to mod h less than delta. So this proves g dash of z is f of z. Yeah. So what we have shown, if f is a continuous function on the connected set u, and if integral of f over any closed path is 0, then f has a primitive. How do I find the primitive? It's very simple. Form the indefinite integral, but the indefinite integral is not along an interval but along a path connecting, fix a point A connected to Z. Okay, right. So please learn these things. In those of you who have problem with the connectedness, path connectedness, I used something extra. Okay, those things. If you are not sure, assume it's convex. Therefore, the proof goes through. Right. So if it is U is an open convex set, if f is a continuous function, so that integral of f over any closed path is 0, then there is a primitive for f. You can go through the proof. Now the paths will be line segments. But still, notice that we may need the g of z is well defined over any path. Where did I need that? Because when I want to define g of z plus h, the obvious path I took was not the line segment joining a to z plus h in the case of convex flow. I took the path z which goes from a to z and the line segment which goes from z to z plus h. Okay, so even then z of z plus h is well defined. That part is still required even in the case of convex domains. Okay, so, and do not get intimidated these things. Okay, as you can see, there are a lot of concepts involved in complex analysis, and it also depends that your reasonable mastery over real analysis. You can see if you are good at real analysis, many of the things will be easy. This kind of estimates, etc., will be easy. You will see the proof is parallel to whatever you seen earlier also. That is why I insist, never ever look down upon real analysis. Learn it very well. Whatever your thing, even if you go to algebra, topology, it will be useful. Okay, we will meet again. Take care, stay safe.